This is video 3.1a for Positive Maths. In this video, we're going to look at natural numbers, integers, rational numbers, irrational numbers, and real numbers. Okay, so we'll start with natural numbers. They are positive whole numbers. The symbol that we use is the capital letter N. Usually in our textbooks we see this letter in bold, or it can also be written similar to this. It's just to ensure that we know that it's the set of natural numbers that we're talking about. So, examples, we're starting off at 1, going all the way to infinity. So, the 3 dots are suggesting that this continues on to infinity. So 1, 2, 3, 4, 5, 6, 7, 8, continuing on. We also need to know how to plot these numbers on a number line. So what we do is we put a circle at each different number. We have to make sure that it's exactly on the number. So 1, 2, 3, 4, and 5, and the arrow at the end is very important to show that it does again continue on to infinity. So our next set of numbers is integers. So integers are positive and negative, so plus and minus whole numbers. So the whole numbers means we're not talking about any fractions. The symbol is a capital letter Z. Again, it can be in bold in our textbooks, or sometimes we see it drawn like this. So again, we have dots at either end to suggest that it's continuing to infinity on both the negative side and the positive side, and it also includes 0. So on our number line, again, like with the natural numbers, because they are whole numbers, we need to make sure that we're only putting the dot exactly where the number is. And again, our arrows at either end show us that it continues to infinity on both sides. Our rational numbers, these really are our fractions. So irrational numbers include any number which can be written as a fraction. This includes positive, again plus, and negative numbers. The symbol is Q. Again, it can be sometimes in bold or like this. So it's any number which can be written in the form of A over B, where A and B are elements of the integers and B is not equal to 0. So for example, A and B cannot be equal to 0, so it cannot be 1 over 0. It cannot be minus 5 over 0. So let's think of some examples. A and in the form of A over B, where A is an integer and B is an integer. So some examples could be 2 over 1, both natural numbers. Could be minus 3 over 2. Could be 5 over 7. So any number written as a fraction is a rational number. So just to talk about fractions for a second, we say that the number at the top, A, is our numerator, and the number at the bottom, in this case B, is a denominator. So if we just take an example of 3 over 4, 3 is our numerator and 4 is our denominator. Moving on to irrational numbers. An irrational number is any number that cannot be written as a fraction, only as a decimal number really. So we must remember that we can write natural numbers or integers as a fraction, so they are not irrational. So for example, 2 we can write as 2 over 1, so that is a rational number, and minus 5 can be written as minus 5 over 1, so that is a rational number also. So neither of those numbers are irrational. So let's think of examples then of irrational numbers. So pi, for example, is an irrational number. 3.142, continuing on. We cannot write this number as a fraction. The square root of 2, another irrational numbers. It cannot be written as a fraction. Real numbers. The set of real numbers includes all numbers. So it's all positive and all negative numbers. Really, any number that you can think of is a real number. The symbol is the capital letter or. Again, sometimes we can see it written like that. So, let's think for a moment about plotting these numbers. You could literally name absolutely any number and it's within the set of real numbers. So it could be minus 3.5, which would be about here. It could be 1.75. It could be minus 2.8. 0. Any number. So we could literally sit here for half an hour, even longer, talking about all of the tiny numbers in between 1 and 0. All of the numbers between 2 and 3. Literally, we could plot an infinite amount of points on this line. So therefore, when we're talking about real numbers, instead of doing the dots like we were doing before, we just do one heavy line. Because really, if we joined up all these dots that we were talking about, we would end up with a heavy line. So it includes all of the numbers. So an example, literally any number. We could put 1.11111. We could put 2.53 minus 7.8. Any number is part of the set of real numbers. So the next video in this series is 3.1b, where we will be looking at natural numbers in more detail. Thank you for watching.